So hello class. Today might be that will be a last topic of this chapter, structure of atom, that includes the some of the more electronic configuration concept, electronic arrangement concept from this chapter. In the last lecture, we had a discussion about the above principle, the concept of electronic configuration, the N plus L rule, the concept of energy ascending rule. And same way, we had some exceptional pairs and elements which are not going to follow the above rule. Now, in the same sequence of electronic arrangement theory, today we will discuss the filling of electron in the different orbitals and the filling of electron in the same orbitals. That is called the Pauli exclusion principle and Hund's rule of maximum multiplicity. And in the last, we have a energy exchange rule to explain the stability of D4, D5, P3, P2, D10. So for a stability reason, for explanation of stability, we have that energy exchange rule. So we have to discuss these three last rules from this chapter. Then we'll have a one lecture at least on Saturday, hopefully based on the exercise. Then from Monday we'll start a new chapter. So first theory is about and second theory is about Hund's rule. Of maximum multiplicity. Hund's rule of maximum multiplicity. Students, these two rules are having a very important role to distribute the electrons in the different subcells and orbitals. According to the Pauli's exclusion principle, no two electrons can have a same set of quantum number. No two electrons can have the same set of quantum number. According to this principle, according to this rule, all the electrons of the atom, if the atom having more than one electron, all the electrons having different nature, different energy, or spin, or energy level, or magnetic behavior, on any ground, electrons must be different from a same atom. And that can be proved on the basis of the quantum number value called NLMS value. And for that, I'm going to compare any two electrons from any atom. For example, suppose I'm taking helium. I'm taking helium, atomic number 2. Electronic configuration is 1s2. So, first electron and second electron. We will find out the quantum number for these two electrons. So, value of N will be L, M will be and S. Let's see the value of N. That is the first cell. N will be 1. That is S subcell. The N will be 0. For 0, M will also 0. But the value of S will be for the first electron plus the same cell, same subcell, and same orbital, the value of n, l, m can be same, but at least on the one ground that is called spin must be different. So according to Pauli's exclusion principle, we can fill any two electron in a same orbital with opposite spin, because the spin must be different for two electrons in a same orbital. It may be possible sometime the cell is same, subcell is the same, orbital is the same, but electrons are different because of spin are different. And this is the reason why we have this type of arrangement. The one upward arrow indicating the clockwise direction spin of the electron first, and this one is called the second. The second one is called the anti-clockwise spin of the second electron. Actually, Pauli want to explain there is not possibility Actually, he want to explain there is not possibility of a parallel spin electron in a same orbital. According to this rule, it was confirmed because of the same orbital, there must be difference of the spin. The electron must be either clock or anti-clock. It will not be possible, means it is impossible to have a same spin electron either clockwise in a same orbital or anti-clockwise in the same orbital. So this is going to be wrong. This is going to be wrong. Actually, with the help of quantum number, he proved that the electrons can have at least different on the basis of spin. One more thing, if the cell is different, the value of n will be different. If the subcell is different, value of L will be different. If the orbital is different, value of M will be different. But if all these above three are same, at least spin will be different. So, according to this calculation, it was proved that in any atom having multi-electronic concept, the all electron must be different on any single ground. Maybe on the basis of energy level, maybe on the basis of orbital called magnetic level, or maybe possible on the ground of spin, the electron must be different. This is all about the Pauli exclusion principle. This principle is exclusive because all electrons are having their own properties of energy, angular momentum, magnetic behavior, or spin. And that's why we cannot compare the electron to each other. They must be different in any single atom on the ground of any one of them. Then after, the Hund's rule of maximum multiplicity proved that electrons enters first with a parallel spin in a different orbitals, then will be anti-parallel in the same subcell. For a same subcell, electron must be first parallel, then will be pairing will start. For example, look at the condition. What does it stand for? Suppose we are having P1, P subcell can contain maximum 6 electrons. Suppose the configuration is P1, P2, P3, P4. So look how the electron can be filled. Actually, according to the Hund's rule, the first electron enter in the first orbital, okay, fine. Now there is a possibility of the second electron. The second electron can be a pairing in the same orbital or can be a parallel spin in a different orbital. Means for the second electron, there is two possibilities. The one possibility, electron enters in the second orbital, or electron will enter in the same orbital with the anti-parallel spin. Anti-parallel spin, but we prove that this possibility is wrong. This possibility is wrong because unless all the orbital will not receive electron, the electron will not be paired in the same orbital, and that is why the P3 first electron will be entered in all the orbitals available. Then the pairing will start. And this is P3. Now electron is going to pair. So the problem is sometimes we going to make a mistake to count the electron. We count as 1, 2, 3, 4. This is wrong. The actual counting is 1, 2, 3, and this one is fourth electron. This one is a fourth electron. So whenever we going to make a count for any electron, the paired electron is actually will be in the last. First we will count all parallel spin, then we will start counting of the pairing of electrons. So this is called a maximum multiplicity. Stand here, maximum multiplicity means there must be first multiply of the spin. Multiply of the spin. All electrons are first multiply, then will pairing start. So this is the condition of P4. The same will be repeating for the T subcells. So simply this rule was actually explain the arrangement of electron in the different orbitals of the same substance. This is called degenerate orbitals. I explained earlier, if the orbitals belong to the same subcell, they are called degenerate orbitals, means having same energy. This is called degenerate orbitals. And in degenerate orbitals, electron filled according to Hund's rule. First, parallel spin will be there, then will pairing start. Now, the explanation, why there is parallel spin? Why not first they pairing first? Why they got one electron in each case, then will pairing start? This is actually based on energy exchange rule. That is called third rule of this topic, and that will be the last rule of the chapter. You can get this rule on the last page of NCERT of this chapter. Before starting exercise, the last page is about the energy exchange rule on NCERT. So you can read through your NCERT book also. So let's learn the energy exchange rule here. Energy exchange rule here, that is according to energy exchange rule, because of the degeneracy of orbitals, electrons can exchange their positions with the different electrons. That will decrease the potential energy. And due to decrease of potential energy, stability increases. Simply, the stability is inversely proportional to the potential energy. You can make down this. You can make write down. Stability is inversely proportional to the potential energy. Lower potential energy for any given system there will be higher stability. So according to this rule, look at the possibility. This is called P2 configuration. This is called P2 configuration. There is exchange of electrons. This electron can exchange with this electron can exchange their position with. So first electron will go here and the second one go in the side of first. So they just actually exchange their position, and due to exchange of position, the potential energy decreases. That will increase stability. Simply, more number of exchanges possible, more stability of subcell will be there. So P2 configuration has only one possibility of exchange. But look at the condition. Look at the P3 condition. In P3, there are 3 exchanges possible. The electron can exchange their position thrice. And these 3 possibility of exchange will make more stable configuration of P3 in this way. This is a more stable. And this is the reason why first electrons are multiplying in a parallel spin. Because the parallel spin electrons are more stable in this condition P3. If they will get pairing, the stability decreases. So Hund actually explained why electron first multiply in a parallel spin, then will be pairing start. Because of the greater exchange will increase the stability condition. Now, the same energy exchange rule can explain the electronic configuration of exceptional element in the above principle like chromium. In the last lecture I explained that D5 will be more stable than D4, and that is the reason that D4, when the D4 electronic configuration come, that will convert it into D5. Because of the stability reason, look at the stability here. D4 condition. There are total number of 6 exchanges. So in D4, the electron can exchange their position 6 times. Now let's discuss about the D5 configuration. D5 configuration. Count the possibility. There are total number of exchanges are 10. So in D5, D5 is very stable than D4 because of more number of exchanges. So simply, if the more number of exchanges there will be more possibility of stability reason, and this is the reason why chromium having configuration S1D5, copper has configuration S1D10, because the half field is always greater, more stable than a lower field. D5 half field. So look at the possibilities. They are called completely half-filled orbitals. The p subcells can have 6 electrons, 3 is half-filled, D can have maximum 10, D5 half-filled, F can have 14 maximum, so 7 is half-filled. These are called completely half-filled orbitals. They are most stable. They are more stable than the other configuration of the same way. The completely filled orbitals, the S2, sorry, P6, the S2, P6, D10 and F14, they are most stable because they now are inert. They are now inert. So, because of inertness, no electron required to fill in the orbital because of completing the maximum tendency of the subcell, they are most stable. So, completely filled orbitals are most stable. Then, completely half-filled are more stable because of exchange rule. And this is the reason why other elements like chromium, molybdenum, tungsten, copper, silver, gold having this tendency to change their electronic configuration from D4 to D5 or D9 to D10. This is all about the chapter. Chapter is completed. Next lecture will be based on some of the questions picked from the exercise. I will try to explain some of the questions, possible questions that can be in one lecture, in a next lecture. So, students, revise all the topics taught. Try to maintain your notes. And if there is any doubt regarding the topic, you can ask me anytime. But most probably, all the topics related to the structure of atoms are already concluded in the different lectures. All lectures are already uploaded. You can see all the lectures for your interest. Thank you.